These are part of the solutions to assignment 16 over probability. And I'm only going to talk about the part that I feel are very important for the SAT. If there is a probability question, uh, here and there can be probability questions, and I'll point you to the page where I think it's most important. So there's basically simple probability, which is just the probability of an event happening versus it not happening. And those two ideas are called the complement principle. So a good example on this first page, you have this jar containing 5 blue, 6 yellow, 7 green. What's the probability of finding a blue? Randomly chosen, of course. So 5 are blue out of the total of 18. The probability of not getting a blue is 13 over 18. I'm not going to get into, so this is drawn from statistics and probability class, once upon a time that I taught. So I'm not going to get into the difference between classical and theoretical probability. Sample spaces, those are just like listing all the possibilities. I'm not going to get into sample spaces, although you're welcome to try this and to look up the solutions if you really want to. Um, I think this complement principle page should be a page that you should study and that you should think about, because I've seen questions on something like this for sure. So this is dealing with really the and principle on example 2. Um, I gotta start with example 1, I guess. The probability that it will rain today is 40%. Find the probability that it will not rain. Okay, 1 minus 40%. Anyway, example 2 is about the and principle and the complement. So the and principle is a multiplication situation, which we're going to get to after this page. But probability that it will rain over a 3-day, so the first day and the second day and the third day. It's an and situation. You multiply the probabilities together. The probability of no rain for at least 1 day is high. So again, complement principle. The complement to not raining over each day over a 3-day period is raining at least one of the days. So the probability of no rain over a 3-day period, so you just do the complement to 40% up here, is 60%. So no rain and no rain and no rain, 0.216, and then the complement of rain for at least 1 day is 78.4%. So there's all these complement principle ideas that I think are very important, and understanding what does it mean to say the opposite of it raining every day for 3 days. There's just at least 1 day of no rain. What's the complement to, or I guess complement situation to the first statement, the probability of no rain every day for 3 days. There it is from the 40%. And then for at least rain for at least 1 day, 1 minus that. And so here's another good complement problem. Probability that this asteroid, God forbid, will hit land. So the land square miles over the total. And then the probability that we'll hit water, you do 1 minus that 0.29. So I think this is very good stuff for the SAT in studying this. I've seen questions on this. I have not so much seen questions on 2 dice probability. You're welcome to try this. It is based on this table. So I'm going to skip through this. You can stop the video, come back to it if you want to check your answers, but I'm going to skip by it. So I've separated these two into experimental probability. So that's different than theoretical, because experimental is based on something that's happened. So like you could be tossing a coin experimentally and get 50 heads in a row. But if you toss it 1,000,000 times in a row, you're probably going to get equal number of heads and tails. So that's the empirical, just means nothing's perfect. Somebody wins the lottery. That's empirical probability. Technically, people shouldn't win the lottery based on the theory behind it. But empirical probability is just what happened in a particular experiment. So you can look at this. I think as far as the SAT goes, I like this table here, questions from a table rolling a 1. So you got 6 chances out of the sum. The sum total of this is 40. And you add those all together. So I think that's pretty good because the SAT likes tables and whatnot. But you can look at this and the answer key if you wanted to, again, get some deep ideas with this. Same way with theoretical probability. Again, I don't think there would be a lot of questions on empirical or theoretical. So theoretical is based on the theory. So what's the theory of flipping a coin and having it land heads up? Only 1 out of 2 times. It should just happen half the time. So that's the difference. You might get a question on the or situation and the and situation and whether things are mutually exclusive or not. So not mutually exclusive means that you can have intersection. So what's the probability of drawing from a standard deck of cards, 52 total, a red card or an ace? Well, the problem is that some red cards are aces, the ace of hearts, the ace of diamonds. So you're counting twice when you're counting all reds and you're counting aces, you're counting the 2, you're counting them twice. So you got to subtract that intersection. Okay, so that could be something. So when things mutually exclude each other, that means there's no intersection. You got one group and another, and there's nothing that belongs to both. And so then you just add the probabilities. So it's important to know with the or situation, what's the probability of drawing from a standard deck of cards, a 10 of diamonds or an ace? They're different. They mutually exclude each other. So if you draw a 10 of diamonds, you cannot possibly draw an ace, and vice versa. So you just add their probabilities, bam. Again, sometimes you have to subtract intersections. So 10 in both, you see, and you'd have to subtract that out. So not mutually exclusive means there's intersection. The and situation, so you actually saw this earlier with the rain problem. So here you multiply the probabilities together, and then do you have independent events? So one doesn't affect the other. Usually there's this with what's called replacement and no replacement of items. So independent means items get replaced or replenished and you're not consuming up possibilities. So like in the lottery, the events are actually dependent because you've got a bin of balls, out comes a number, and that number stays out. So because that number comes out, the second event's dependent upon what that first number is. So the lottery is an example of dependent events. Independent just means you load back up with everything. You replace it. So independent versus dependent events, you can get pretty crazy with that. But the whole point is with the word and, okay, you have to multiply probabilities together. Okay, so you have this chart. So I'm coming down to this chart because the SAT just loves chart problems. Let me zoom in and do this a little bit. So what's the probability that both students are ninth graders? So 8 out of 10, the first one's drawn, you keep that out, times 7 out of 9. So because you've already drawn a ninth grader, then you only have 7 choices out of 9 for the next one. Dependent events, all the way down. What's the probability both are 10th graders? 2 out of 10, then you pick that one, first one's a 10th grader, and then the second one, you only got 1 out of 9 left. What's the probability that the first student is a ninth grader? 8 out of 10, and the second is a 10th grader, 2 out of 9. So these are all dependent events because you're not replenishing what you're drawing from. Okay, and independent means that you got to think a little bit. Multiple choice test has 5 questions and 4 choices for the answer. There's only one correct answer. What's the probability you randomly guess the correct answer to all 5 questions? So you got a 1 out of 4 and times 1 out of 4 and times 1 out of 4. So the probability 1 out of 4 happening 5 times to the 5th power. Those are independent events. Has a lot to do with, although it's not always that, independent events. Notice the denominator is the same. Dependent events, no replacement. Dependent events, no replacement. Denominators change. Independent events, replacement. Okay. And then there's this assignment at the end, which isn't the greatest for probability. You might want to try some of these, but some of these problems were not the best. 1 and 2 were okay, but some of them got really kind of off kilter from what really is on the SAT. I kind of like the spinner problem. That's pretty good. Anyway, I'll just show the answers. I probably don't really, oh, okay. Hopefully you watched the video. Geometric probability. This can be on the SAT. So you just figure the area of what it is. So what's the area around this? You got to subtract the areas, 10 times 10 minus 8 times 8 over the total. So 9/25, and then 1 out of 4. So geometric probability is everything here. So 30 degrees out of 360. This is good. This is the best of the probabilities apart from what I just got done talking about. So it's a geometric type of thing. Here it's like a circular 30 degrees out of 360. Okay, so that's probability. There might be one question. So that's why we kind of put this at the end. The stuff on geometric is good to look at. And then some of the stuff that I talked about, especially the rain problem, with how they like to ask questions on the SAT.